Intro Algebra Lesson 5-2b. We started off dealing with linear equations and our ability to take information and write that equation very simply by using slope-intercept form y equals mx plus b and plugging a value in for the slope and plugging a value in for the y-intercept, m and b, and we would have our equation. And the last time we stepped that up a little bit, where we were still given the slope, but instead of given the y-intercept, now we were given a coordinate, and we could use the slope and the coordinate, substitute the values in for y, m, and x, and solve for b. Then that would take us back to being able to use the slope and the b and write our equation. So under that same guise, this is kind of what we were talking about, we substituted in all the known values and solved for b. That allowed us to then write our equation y equals mx plus b with the m that was given to us and the b that we found from step 1. Y equals mx plus b. And this will really be no different today. We're going to use that same concept, however, with a twist. And usually what messes people up is when some sort of information is presented in a different way, they think the problem is different. So in reality, I want you to compare and look at these and say, really, they're the same problem. The information is being presented to me in disguise. So our first example here, write an equation of the line that is parallel to the given line but passes through the given point. Now this may seem different than the last problems, but in reality it's the same. So I'm going to give you an equation and a coordinate. So here's the equation y equals x plus 4, and here's the coordinate. Now last time you were given a coordinate, so that's not any different, but last time you were given a slope. And so people look at this and they think, well, this is a different problem, I'm getting something else, it's not the same. Really, I'm giving you the same information because of this key word parallel. So the idea behind parallel is that parallel lines have equal slope. So when you're looking at two lines, and this has a rise of 3 and a run of 1, and this one also has a rise of 3 and run of 1, then the lines would be parallel. They'll never intersect because they go up and over at the exact same amount. That's what makes them parallel. They're equal slopes. So this equation has a slope. It's very close to being y equals mx plus b, we just don't see the slope. If we stick a 1 right there, now we have y equals mx plus b, which means the slope is right there. It's 1. If our line, our new equation, I'm not going to do anything with this equation, if our new equation is going to be parallel to this one, that means that our new equation has to also have a slope of 1. The only question is, what's the new b? We're not going to have the same y-intercept. We're going to have something new. And that's where this information comes in. Because I have an x value and a y value, just like we had last time. I'm going to stick that -2 in for x, and I'm going to stick that 0 in for y. So I have a 0 equals the 1, and I know that's 1 because it's parallel to the other equation, and I'm going to stick -2 plus and then solve for b. So once I have plugged the slope from this equation into my new equation, because that's why they're parallel, then I'll be good. A couple mistakes that people make. They try to use this equation. They try to stick this -2 in for x and this 0 in for y and make something work. It will not work. We are not doing anything with this equation. We're basically a slope thief. We're going to steal the slope from this equation and we're going to use it for our new equation. Other than that, we really have no need for this other equation. Forget about it. Steal its slope and forget about it. It'll be the exact same as before. So now I've got my new information. I can say 0 equals 1 times -2 plus b, which means 0 equals -2 plus b. Add 2 to both sides, and we have our new situation of 2 equals b. So I have a slope of 1, and I have a y-intercept of 2. Now I can write my equation, y equals 1x plus 2. That's it. How does it compare to the original equation? It has a different y-intercept because it's a different line, but it has the exact same slope because they are parallel. Parallel lines have exactly the same slope. So I'm stealing it. This may seem different, but it's very similar to the last problems. Let's try another one. Same idea. We know the equation is going to be parallel. Here's the equation and the coordinate. Now this time what you'll notice is that the slope is -3. What does that mean? That means that our slope on y equals mx plus b is also going to be -3. Since that's -3, we are going to have a new equation that's -3. Am I going to do anything else with this equation? Nope. I'm not going to do anything else with this equation. I am going to take this x and this y, and I'm going to substitute 4 in for x, and I'm going to substitute 2 in for the y, and now I can solve for my b. So I'll say 2 equals -3 times 4 plus b, which means 2 equals -12 plus b, and I can add 12 to both sides, which means 14 equals b. So as far as my equation, y equals -3x plus 14. When you compare, they both have slopes of -3, which means they are parallel. So now, I can either give you a slope, and I can give you a y-intercept, and you can make an equation, because you'll just plug in the slope and the y-intercept, and you've got your y equals mx plus b. I can give you the slope and a coordinate, and you can solve for b, and then write your equation. Or I can give you a coordinate and tell you it's parallel, which is just a code or a tricky way of telling you the slope. I can tell you it's parallel to another equation, so you can steal its slope and use it, but don't do anything with that other equation. It's out of your mind once you steal its slope. So you actually have quite a bit of flexibility, and information can be presented to you in a number of different ways. You just have to be keen enough to figure out what parts are similar to what you've done before, and how can you be a detective and pull out the important needed information.